So far, when we created our fraction class, we now have constructors, and we have 3 constructors, and we have some methods. I didn't include all the methods. Our accessor and mutator methods that we covered last class, and it's time to add some more. If I now open a new class, I'm going to call it testing. I'll include a main and press finish. Just going to get rid of some of the comments we don't need. Now if I create a fraction, say fraction f equals new fraction, and I pass it 2, 3, if I print this fraction, I would like 2 over 3 to be printed out. But as we know, if we were to run this, what it will print is essentially the memory address. That's the value that's stored in the reference. But if I was to print something, for example, if I was to define a string equals new string, so the definition looks the same, and I print this string out, Java knows that I want to print out hello. I don't want to print out the memory address that it is stored at. So there's a mechanism for that. I spoke the other day about the object class, so the Java object class. And if we look at that, we can see they've got, we're going to get to today as well, what's called the equals method. And that's the object class as equals method is simply just checking the memory locations. This other special method, which is called toString, is supposed to return a string representation of the object. But for the object class, it only knows about references. We can define or override our own toString method. So I'm going to go back to the fraction class, and typically we put the toString method at the bottom, so it's easy to find. It's going to be public. It's going to return a string, and it must be called toString with a capital S, and it takes no parameters. Now, like I said, this is supposed to be a string representation of the instance variables. We have 2 instance variables in the fraction class, num and den, representing denominator. So I'm going to define a string, and I'm going to put in here the values. I'm going to say this dot num plus, I put the division sign, and this dot denominator. And I simply return this. I save this. I go back to the testing class. Now without doing anything, I run the same code. And I think it's calling, this is fraction from another. I'm going to pause. So it seems that I was pressing the, running the incorrect testing fraction class. So if I now press run, rather than the memory address, you can see hello is printed out. Java, if a class has the toString method defined, will print out that toString method. Now if I create another fraction, say fraction f2, and I give it the same values, so 2, 3. I'm just going to take out these lines. And I print out F2, and I run this again. You can see 2/3 is printed out both times. Now, if I want to check if they're equal, so I just print out the Boolean value of their comparison. So I say F equal F2, I run this, this is false. But if I recall back from the string class, I can compare if two strings are equal by using the equals method. So if I try a similar approach here, system.out.println, I say f dot equals f2, I would want this to output true. But we will find that it still outputs false. And in a similar case, the big O object class does have an equals method, but we have to override it in our fraction class to tell Java what we mean in terms of fractions, what makes two fractions equal. So I'll go to my fraction class, and just above my toString method, I will put my equals method. So it always, if we're overriding a method, it has to have the same signature, which means it has to have the same return type, the same name, and the same parameters. So I'm going to say return a Boolean. I call it equals. And I'm going to pass in another fraction, which is an object as well. So we know that two fractions are equal if the numerators are equal and the denominators are equal. So I'll say return f this dot numerator equal this dot f dot numerator and this dot denominator equal f dot denominator. And I'm just going to indent this by selecting Control A, Control I, indent, spacing, etc. Now we go back, so I haven't touched now this main class, and I go to run this, and it should now output false and then true, because the memory addresses are different, but the fractions represent the same. Both classes, both objects represent the same fraction. Yay, it worked. So now, if I go to your website, you will now have enough knowledge to get started on the latest mini assignment, which is this O3 classes and objects. You'll be creating a circle class with 3 constructors, accessor and mutator methods, various other methods, an equals method, toString method, and I would also, as you're developing each of the constructors and the other methods, number 12 asks you to create a test circle class. Create that first, well, after you've created the circle, after question 1, just so you can test things along the way. So that's it for today.